Welcome back to Advanced Functions, MHF4U1. This is Combinations of Functions chapter. In this lesson number 5, we're going to determine the composition of two functions both numerically, graphically, and algebraically. So we will be looking at the composite of a function compared to what we've been doing so far. Now let's go over some definition. Now, any function, f of x, can be imagined as a machine, f, who changes the input x into the output y. Okay, so you can think of like f as like a vending machine where you put in a coin, which is x, into the vending machine, and you get an output, y, which is like a can of Coke. Now let's connect now the output of the function machine g as the input of the function machine f corresponding to a different function. So what's going to happen is now the input is going to go into a different function g, and then you get an output y. And then whatever the output you get, you're going to put that output back into as an input of a function f, and you get the final output of z. So as you can see, z is the outcome when you input y into function y, f. So this is the following information. Y is g of x, my first function, and z is f of y. So this is the summary of the composite function. So z is equal to f g of x. So what this means is that g of x is the input into function f. So we have a function going into another function. So we can replace the machine g and f by a new machine, which we call f. You see the circle and then g. That is a composite who changes the input x directly into the output z. So this is a combination of function f and g. Now the order is very important. So f composite of g means that f and g of x is the input. But on the other hand, if g is a composite of f of x, that means g has to come first and then f. Okay, so same idea. You can have a function f of x going into another same function. So we have a given function going into the same function, or we can have a g of x going into the same itself equation, function as well. So please be careful. Is it g composite x of f, or is it f composite of g? Okay, so the order will be very important. Okay, so this is the symbol that you always have to be familiar with, composite function. What about the domain and range? So for domain and range, let's do domain first. So f composite of g is a subset of the domain of function g. So what you have to do is figure out x is pretty much belonging to the domain of function g, and g of x is a subset of the domain of function f. Okay, so this will be the restriction and this will be the domain based on the second function. Okay, so we can consider g as the inner function, which you're going to calculate it first, and then f is the outer function. And this is where we're going to calculate the second time, and this is the first calculation that you're going to do. Now, how do you read it? So this can be read as f of g of x. So what that means is f composed with g. Now, the domain of f of g consists of the numbers x in the domain of g, such that g of x is the domain of function f. And it's the same idea. It's the other way around. The range of f of g is the subset of the range of f instead of g. Okay, so this diagram will be a little bit more clear understanding. So let's say we're looking for this is my composite function. So this is the domain of function g. This is my inner function. And this will be going into my function g over here. The range, so this is talking about range, but I'm talking about the domain. Okay, so the domain for f of g is going to be based on the domain of function g here. And the range of the function f of g is going to be dependent on the range of function f. Okay, so keep that in mind. So domain for f of g is dependent on the domain of function g, the second one. On the other hand, the range of function of g, f of g, is going to be belonging to the range of function f, the first one. So it's the opposite. So I would put a square box on this. Okay. Let's do a practice question. So example 1. Given f of x, which is a square root, and g of x, which is a parabola, determine the composite function f of g of x. So I'm going to rewrite this as the outer function is f. My inner function is going to be g of x. That means let's put g of x, which is this one, into function f. So function f is this, right? And then g of x. Do you see that? So I replaced f with square root. And now I'm going to replace g of x as x squared minus 4. Okay, so always do the outer first and then inner when you're doing it, when you're replacing it. Okay. Now, what about the domain? So keep in mind, we want the inside of the square root to be greater than 0. So x squared minus 4 greater than or equal to 0. So x squared is greater than or equal to 4. So if I square root it, it's going to be plus or minus. So if it's plus or minus, it's absolute value greater than or equal to 2. So that will be my domain for this function. Next, we're given g of f of x. So I'm going to rewrite it as g is the outer function, f of x. So let's replace g as x. So x in this case is f of x squared minus 4. Now we know f of x is going to be square root of x squared minus 4. And then they cancel out, so it's x minus 4. Now for domain, x has to be greater than or equal to 0. Right? Because we're taking the square, even though it's linear, we had square root before. So under the square root, it has to be greater than 0. Okay, so this will be my domain, and this will be my final statement. Now, what about the domain of f of g of x? So this means f of g of x. Now, so for f of g, the domain we saw from letter A, it was absolute value greater than or equal to 2, right? So if I have to draw a number chart, this actually looks like -2 and 2, close circle, greater, and close circle, less than, right? So therefore, what that means is that domain f of g is going to be x can be any real number such that x is less than or equal to -2, or x must be greater than or equal to 2. Okay, and that will be my domain for function, combination function of f of g of x. Number 2. So we're given logarithmic function and a linear function and determine f of g of x and its domain. So let's rewrite it, f of g of x. This can be rewritten as f of g of x. And so we know f, let's always start from outside. It's going to be log 2 g of x, right? And now I'm going to replace g of x, so it's log 2 x plus 4. So that is my final function. But for restriction, we need to make sure that this inside the bracket, x plus 4 has to be greater than 0. So then x must be greater than -4. So therefore, the domain in this case, f of g, is x can be any real number such that x must be greater than -4. And that's my domain. Now, so show that f of x, which is a reciprocal function, then, okay, so do you remember f, you see the -1 superscript? This is the inverse function. Okay, so inverse meaning you're going to switch. So we need to prove that this statement is equal to this statement. Okay, now let's start with f of x. So let me rewrite this. F of x is equal to x plus 2. So let's start with the first statement. So the first statement is we have, let's find f inverse. Okay, so first to do the inverse, I'm going to replace f of x to y. That's always your first step for finding inverse. Okay, and then I'm going to switch x and y now. So x is equal to 1 over y plus 2. So I'm going to crisscross, cross multiply. So it will be x times y plus 2 equals 1. And then I'm going to do isolate it. So therefore, I'm going to y plus 2. So y plus 2 equals 1 over x. So I'm going to move x to the other side. And then y is equal to 1 over x minus 2. Okay, and then I don't like this form, so I'm just going to make a same denominator. So I'm going to multiply this by x and this by x. So therefore, y is equal to 1 minus 2x over x. So I could say f inverse, replace it back, is 1 minus 2x over x. And we have to say x cannot be equal to 0, right? And from the previous, from my initial, x cannot be equal to -2. Okay, So that's the restriction for my inverse. Now what about, so let's do the second part. So we will do, okay, so first, let's do f of f inverse of x. So this essentially means f inverse x, right? So I'm going to replace f with 1 over f inverse, and then plus 2. So I'm working on the outer function. I replaced function f. And then I'm going to replace inverse function into this bracket. So 1 minus 2x over x plus 2. Then I'm going to make the same denominator. So it's going to be 1 over 1 minus 2x plus 2x over x. And you'll notice that these two cancel out. So I get 1 over x. So when you divide it, so I can make 1 as 1 over 1, in, out. So outside goes in the numerator, and inside 1 times 1, so it's just x. Okay, so let's move on to the next page for space. Then the third part, we have to look at this part. This was the second part. The third part is f inverse of f of x. So this essentially means f inverse, that's the outer function, f of x. So let's replace f inverse as 1 minus 2 f of x, this is my variable, over x, which is f of x. Then 1 minus 2, f of x is 1 over x plus 2 over 1 over x plus 2. Okay, so then I'm going to do the distributive property here in the numerator. So it's going to be 1, so let's make it same, 1 minus 2 x plus 2. So then I'm just working on the numerator right now. So it's going to be x plus 2 minus 2 over x plus 2. Okay, so I multiplied 1 with x plus 2, top and bottom, to make it same denominator. Then you will notice that these two cancel out. So therefore, it's going to be, for the numerator only, it's going to be x over x plus 2 over 1 minus x plus 2. Okay, then again, inside, outside. So outside you multiply and it goes in the numerator. So x times x plus 2. And inside, when you multiply, goes in the denominator, 1 times x plus 2. And then you'll notice that these two cancel out, so you're left with x. Now what do you notice? We have the same answer, x equals x. So therefore, we can prove that f of f inverse of x is equal to, which gave me x, to f inverse of f x. X equals x. So it is true. Left side equals right side. So when you get a question like this, first step, going back, is I would figure out finding the inverse of a function. And then after you figure out the inverse of a function, then work on the left side first and then the right side and see if you get the same answer. Okay, so I numbered it for you into 3 steps, 1, 2, and 3 steps. Okay, so hopefully that will help you with organization with questions like this.